All right. Hello, class. This disembodied voice is Mr. Lowe. I am recording a few of these lectures to try to get everyone on the same page. So, pay attention. Today we are going over lessons 1, 2, and 3. Okay? So, let's get right into it. Reference point. What is it? So, if you're in a room, right, let's say you have a door here, windows on this side, you're here, and another person is here. If you want to describe your location to a person here, you need to have a reference point or a way that this person can know where you are in relation to the window, the door, or the room. I know it sounds a little complicated, but we'll try to break that down as best we can. So, what is a reference point? A reference point is the starting point you choose to describe the location or position of an object. Now, what does this actually mean? A reference point is an arbitrary position, meaning that the actual spot you pick doesn't matter. What matters is the movement or location of the object in relation to the point you pick. So how does this work in real life? Let's say I'm inside the classroom. You guys all know there are projectors in there. So if you were to describe my position, a lot of people would just say, oh, he's over there. But scientifically, you could say, oh, here's the projector in the middle of the room. Here's Mr. Lowe. Oh, he is 10 feet south of the projector. And instead of just saying, oh, he's over there, we don't really say that in science, right? We don't say that. This is a no-go. So you could say he's, 10 feet south of the projector, right? Let's say the square is the projector, that's me. So it doesn't really matter what you pick as long as you're consistent with that reference point throughout whatever you are observing. Okay? Does that make sense? I hope so, because I cannot hear you. Famous reference points. You guys can go on the slides and check this out. You have access to it. This is a fun slide, so we're not going to go over this. So, position. What is position? A position is an object's distance and direction from a reference point. You need 3 things to know the position of an object. You need to know a reference point. A well-defined position has a reference point, a direction from the reference point, and the distance from the reference point. So if I'm walking, let's say I'm walking down to McDonald's. All right. Here's the Alco Park. Okay. So if I were to ask you where is the McDonald's, and here's a little compass. South. If I were to ask you where is the McDonald's from the Alco Park, or where is the McDonald's, I would tell you the McDonald's is 100 feet north of the Alco Park. So the McDonald's is 100 feet north of the Alco Park. It is a reference point, which is Alco Park, a direction north, and the distance. We'll do 100 feet. All right, that's all you need. So, next thing we're going to talk about is distance versus displacement. Distance is the total length of the path traveled. Displacement is the difference between the initial or starting position and the final position. So if let's say this is a city block here. Okay. Sorry, bear with me. My drawing skills aren't super fast. Okay. Okay, these are supposed to be roads going between the city blocks. Okay, this doesn't look that great, but if I'm in my car here and I'm driving up and I go this way, right? Let's say this path I drove 4 miles to drive around the city, right? This is my end position and this is my start position. The displacement is the distance between the start and end position. It does not care about the pattern it does not care about the path you traveled. It does not care about buildings that are on the way. It doesn't care about anything. It is simply the shortest distance between where you start and where you ended up. Same thing if you're going around a track. You know, like a NASCAR track. If a NASCAR race car drives halfway around the track, they've gone 500 meters. But their displacement is from here to here. So the displacement is going to be much shorter. So the displacement is this line here. We'll do it in red. It's going to be much shorter. Okay, speed is the measure of the distance an object travels in a given amount of time. We measure average speed. We write this as V bar. V bar. This means average speed or velocity is equal to time over distance. Okay, so this is our formula for finding average speed. Let's do a quick problem together. If let's say I drive 180 miles in 3 hours. We need to find the average speed. Let's plug it into our equation. Our time is 3 hours. Our speed, our distance is 180. Oh. All right. I need everyone to ignore what I said. It's distance over time. Sorry, I don't have time to go back and edit this, so I need you to remember this. Sorry, distance over time. So our distance is 180. Our time is 3 hours. 180 miles, hours. If we simplify this down, we get 60 over 1 miles per hour. Now, don't forget these units stay here too. So we're going to rewrite this answer as 60 miles over hours, or 60 miles per hour. Now, you may encounter a situation where, they say let's say a car travels 60 miles per hour for 60 miles per hour and went 240 miles. How long did it take? Well, we can figure this out because we have everything we need. We have the average speed as 60 miles per hour, so we put that in here. We have the total distance they went, 240. All we need to do is solve for time. Now we're just doing basic algebra. So we multiply both sides. Sorry, I messed that up again. Boy. So we multiply both sides by t. T, cross these out, 60t equals 240. Divide both sides by 60. And we get t equals 4. Sorry, that was a little messy, but if you have one thing, you can get the rest of it. If you have two of these, you can get the rest of them. Okay, so velocity. Velocity is the speed and direction of a moving object. In physical science, when we're using the information and putting it down, we refer to velocity as a vector. So a vector is a quantity that has both magnitude, the size of the arrow, and speed, magnitude and direction. So let's make some velocity vectors. Let's say this is our field, right? North, south, west, north, and south. So if I'm in the field, and this is my velocity vector, and let's say, I don't know, this is Ashad's velocity vector. Okay, so this is me, this is Ashad. Okay, so what can we deduce from our velocity vectors as we're running through this field? Well, I am going in a northeast or southeast direction. Ashad is going in a north direction. So I'm going southeast, Ashad's going north, because you can tell from the arrows which direction we're going. Now, we don't know exactly how fast me or Ashad are going, but because Ashad's arrow is twice the length of me, you can assume his magnitude is twice mine, therefore his speed is twice mine. Alright, makes sense? I hope so. Alright, we didn't get into this, you're good. Alright, let's get into lesson 2. Lesson 2. So, what is force? Force is defined as a push or pull on an object. Force can affect an object in two ways. It can change an object's velocity or change an object's direction. Let's say you're in a car. Let's say this is our horrible car. And you're driving this way. Now, two things can happen. One thing is another car could come directly this way and hit you head on. What's going to happen? Is there going to be force? Yes. Is that going to change your velocity? You bet. When this car hits your car, you guys are both going to slow down. You're going to have a change in velocity.